Welcome back. We are going to talk today about multiplying polynomials, but let's do a little skill review. So take a minute and hit pause and work through these 3 problems in your composition book. And when you're ready to join us, hit play and we will go over the answers. All right. If we go over the answers, the first question said, determine if the function is a polynomial. Many of you might have looked at that square root and determined it's not a polynomial. However, when you look at this term underneath the square root, this term right here, it's actually an integer and not a variable, so that is okay. We can have that in a polynomial. So if we look at what's going on and put this in standard form, the highest power comes first, which is a 3, so 4x cubed comes first, the negative 5x squared comes second, and the constant comes last. It's cubic because it has a degree of 3, and it's a trinomial because it has 3 terms. Number 2, state the degree. This is one of those cases where we have more than one variable, so we're going to take the exponents and we're going to add them together. So here I get 6. If I add these two here, don't forget there's a 1 right there. Here I get 4. And here there's a 5 and a 3, which add up to 8. So the highest power of these terms is 8. And simplify the expression. If you make sure that you distribute this negative to this term and to this term, you should end up with negative 7r squared s minus 7rs. All right, let's go to our properties of exponent card. The first property we are going to write today is the property that x to the 0 equals 1. So go ahead and write that property on your properties card, and then I want you just to put your pencil down and I want you to watch what's happening and why this happens so you'll have a better understanding. So if we look at 2 to the 4th, well, I'm going to come down here. 2 to the 1 is 2, 2 squared is 4, 4 times 2, 2 cubed is 8, and 2 to the 4th is 16. So now if I think about what's happening, as I go this way, from this term to this term, and this term to this term, hopefully you see a pattern. 2 to 4, 4 to 8, 8 to 16. So if I think about what's really happening, I'm really multiplying this by 2. So what if I reverse that pattern? So 2 to the 4th is 16, but to get to 2 to the 3rd, I only have 8. And now I have 4, and now I have 2. So if I think about what's happening, I'm just undoing that pattern. So instead of multiplying everything by 2, this time I'm actually going to be dividing by 2, dividing by 2, dividing by 2. So if I take 2 divided by 2, here I should get 1. And if I have 1 divided by 2, I should get 1/2. And this matches up with 2 properties that we've talked about. Anything to the 0 power is 1 because a number divided by itself is always going to be 1. And here, if you think of 2, this is really 2 over 1 to the negative 1. And the negative power is the reciprocal power, and that's why we basically flip the fraction. So let's see if this pattern holds true for the 5s. So here we have 5. 5 squared is 25. 5 cubed is 125. And here we have 625. So to go from here to here, I multiplied by 5. I multiplied by 5. And I multiplied by 5. However, to reverse this pattern and go backwards, I divide by 5, divide by 5, divide by 5. So if I continue the pattern, 5 divided by 5 is 1, so anything to the 0 power is 1. And here, remember that this is really 5 over 1, and if I take the reciprocal of 1/5, it's 1 over 5, which is 1 divided by 5. So now I have x squared, x cubed, x to the 4th. So to go up, I'm basically multiplying each of these terms by x, and to go down each level, I'm basically dividing each term by x. So here I divided by x, divided by x, divided by x. If I take x over x, I get 1. And here, this was x over 1. And if I take the reciprocal x over 1, I get 1 divided by x. So hopefully that leads you to a better understanding of our new exponent property. Anything to the 0 power is 1. All right, so if we take the 0 power property and we apply it, if I look at my first problem here, I have all 3 of these terms right here, and because parentheses are a grouping symbol, they are all grouped together, and everything in that group is raised to the 0 power. So everything here is raised to the 0 power, therefore this is going to simplify down to 1. This looks different than the problem on the right. So if I look at the problem on the right here, this 0 only applies to this term right here. So when I look at this, nothing happens to the 3. Nothing happens to the a cubed, but everything here is going to turn into 1. So b to the 6 raised to the 0 is essentially going to be 1. So at the end of the day, right here, I'm going to end up with 3a cubed. Okay, I'm going to add 2 more properties to our property card. These are 2 properties that are very easy to get confused, so we are going to explain them. So let's go ahead and write the 2 properties on your card. The first property right here is x to the a times x to the b is really x to the a plus b. So these 2 x's have the same base, so both of those x's are the same base. So we are able to add those exponents. If you look over here, we have x to the a raised to the b. So this is what we call our power to a power property. When we have a power raised to a power, I come over here and I'm going to multiply those 2 powers together. So just take a minute, put your pencils down, and let's just watch what this really means. So when I think about x cubed, I think that x cubed is really x times x times x. And I think of x to the 4th as x times x times x times x. So when I look here, I really have 1, 2, 3, 4, 5, 6, 7 x's. So this is x to the 7th. And if you think about it backwards, I got that because I took x to the 3 plus 4. So how is that different than the power to a power property? So if I have x cubed to the 4th power, this 4th power means, hey, I'm going to multiply it by itself 3 times or 4 times. So I'm going to take x cubed times x cubed times x cubed times x cubed. And when I do this, now all of these have the same base, so I'm going to apply the same base rule. This is really x to the 3 plus 3 plus 3 plus 3, which is x to the 3 times 4, or x to the 12th power. So a couple examples. So here we have 3 examples. So hit pause, take a minute, and write all 3 examples on your note card, and then hit resume when you are ready to go. Okay, perfect. So let's take example 1. So remember, apply numbers with numbers, or coefficients with coefficients, and then exponents with exponents. So here I have a 5 and a 2, so 5 times 2 is 10. X and x have the same base, so this is going to be x to the 2 plus 3. And then y and y have the same base, so this is going to be y to the 4 plus 1. Don't forget there's a little place holding 1 here. So in the end, I have 10 x to the 5th, y, 4 plus 1 is also 5. So now, if I look at the second problem, I see pretty quickly that I have a 0 right here, and anything to the 0 power is 1. So I'm just going to get rid of that and put a 1 in its place. Here I have 2x to the 5th cubed. So this cubed is actually getting applied to this, and it's getting applied to this. So it's going to be 2 cubed, and then x to the 5th, and this is a power to a power, and when we have a power to a power, we multiply. And then the times 1 at the end doesn't really have any meaning. So 2 cubed, 2 times 2 is 4, 4 times 2 is 8, x, 5 times 3 is 15. So this is x to the 15th. And last, we have a fraction, no big deal. This is going to be a power to a power problem. So you have to remember there's 4 terms in here, 3, x cubed, 2, and y to the 4th. So this 2 is really going to go to every single one of these terms. So in the end, I have 3 squared, x cubed squared, a power to a power, all over 2 squared, and then y to the 4 times 2, power to a power. And then you can take a minute and you can simplify all of this. 3 squared is 9. 3 times 2, x to the 6. 2 times 2 is 4. And then you have y to the 8th. So that is all for our exponent properties. So let's flip to the card that says f.2 multiplying polynomials. So we're going to take the distributive property to a whole new level. So now we are going to multiply monomials by binomials, trinomials, polynomials with 4 terms, and it works just like the distributive property when all you had was a coefficient out front. So take a second and write this problem. And now let's get ready to multiply. So the distributive property says this 2x cubed y will actually be multiplied by each of these terms right here. So 2 times 4 is 8. X cubed times x to the 1 is x to the 4th. Y, because remember there's a 1 here and a 1 here. Y to the 1 times y to the 1 is y to the 1 plus 1, which is 2. Now I'm going to apply the outside term to the middle term. So 2 times 7 is 14. X cubed times x to the 1 is going to give me x to the 4th. And then I don't have a y in my middle term, so I'm just going to go ahead and multiply by the y. Watch your signs here. You have a negative. So 2 times 3 is 6. X cubed times x squared is x to the 3 plus 2, which is x to the 5. And you have a y to the 1 out here and a y to the 6 here. So y to the 1 plus 6 is y to the 7th. And that's pretty much all there is to the monomial on the outside. So let's get to the fun stuff. So multiplying a binomial times a binomial or a binomial times a trinomial, I'm going to basically teach you 2 ways. You could use method 1 or you could use method 2. Different people find different methods easier. So I'm going to come over here and I'm going to take method 1, which I call the double distributive. So DD for double distributive. So you have 2x minus 5 and we have 4x plus 3. So the first thing I'm going to do is I'm going to take this first term and I'm going to distribute it here and I'm going to distribute it here. And when I do that, 2x times 4x, 2 times 4 is 8, and 8 times 8 is x squared. And then I'm going to take the 2x, so I'm going to multiply it over here by the 3. 2x times 3 is 6x. And that's the first part of the distributive property, part 1. So then I'm going to take part 2 of the distributive property. So part 2 of the distributive property says I'm going to take negative 5 and I'm going to multiply it here. So negative 5 times positive 4x is going to give me negative 20x. And then negative 5 times 3 is going to give me negative 15. Now that I'm done with the multiplication part of the problem, I could add like terms. I have an 8x squared. There is nothing that matches up with them. I can see right now that I inadvertently left off an x. So when I took the 2x times a 3, this here should have been a 6x, not just a 6. So I'm going to take my 6x and my negative 20, and this is going to become negative 14x. And then I'm going to bring down my negative 15. Some people see that really confusing and it has a lot of steps. So what I'm going to do is I'm going to come over here now and I'm going to show you the box method. This is kind of like the Punnett square that you learned in elementary school or junior high, where we set up a little box and we do a little multiplication magic. So this is going to be 2x minus 5, my first binomial here. Make sure you have all the correct signs or this does not work. So just like biology, this box here is going to be 4x times 2x, which is 8x squared. To get to my second box, I'm going to take 5 times 4x, the row by the column, and this becomes negative 20x. This box here, I'm going to take my 3 times my 2x here, which is going to give me 6x. And over here in my last box, I am going to take this row times this column, which is going to give me negative 15. When I do the box method, I tend to have matching terms on my diagonals right here. So if I rewrite everything, I pull down the 8x squared. 6x minus 20x is a negative 14x, and then I subtract my 15. Either one of these methods will work. I really don't care which method you prefer. I'm going to be using the box method when it comes to factoring, so I would like for you to do a few of your homework problems using the box method, but whatever will work. So let's try this one. This is the same thing as we just did. You can come over here and you can try method 1. I'm just going to reorder these and put the 2x cubed minus 5x first. Don't panic that this is a trinomial, 4x squared minus 3x plus 5. So those of you wanting to do the distributive method, you're going to have to distribute to 3 terms. So term 1 goes to all 3 of these. Then I'm going to come down here and term 2 goes to all 3 of those. Those of you who would like to get started on the box method, it doesn't matter. I'm going to do 3 columns and 2 rows. It works the same no matter which way you do your box. So over here you have 2x cubed. You have a negative 5x. Up top I will have 4x squared minus 3x plus 5. All right, so just hit pause, work through either method. I'm going to work them both here real fast, and you can check your answer when you're finished. All right, 4 times 2 is 8x, and 3 plus 2 is 5. 2 times negative 3, 6x to the 4th, and 2x cubed times 5 is 10x cubed. Kind of like I showed you yesterday, I will stack my numbers. So when I take negative 5x times 4x squared, I get negative 20x cubed. So I will come right here and I'll put my negative 20x cubed right here, because that way my identical terms match up and it just makes the addition cleaner. Negative 5x times negative 3x is positive 15x squared. And then a negative 5x times 5 is negative 25x. So now I can add my columns down, x to the 5th minus 6x to the 4th minus 10x cubed plus 15x squared minus 25x. The long one. Okay, and here if you did the Punnett square, 2 times 4 is 8, so this is 8x to the 5th, negative 6x to the 4th, 2 times 5 is 10, 10x cubed, negative 20x cubed, 15x squared, and negative 25x. So now if I look here, the only 2 matching terms I have are my cubic terms. So here I have an x cubed and another x cubed. So that's going to combine to give me this negative 10x cubed. Other than that, you just rewrite it just like we did in this polynomial. So what happens if we have a polynomial squared? So if I have to pick one of my top 10 mistakes in the past 27 years that I see class after class and year after year, other than signs, this might be number 2 on the list. So if a polynomial is squared, you have to remember that squaring a polynomial means you're going to multiply it by itself. So we take our grouping symbol, 5x minus 2, and we're going to take whatever is inside that parenthesis and we are going to multiply it by itself. So 5x minus 2 times 5x minus 2. You can do method 1 or you could do method 2. I don't care, hit pause and let's multiply. All right, coming back together, in the end, if you did all of this work, you should have 25x squared minus 20x plus 4. So if you don't have that, just double check your signs and your multiplication. I want to leave you with a problem. It's a student error analysis problem. I want you just to hit pause. I want you to determine what the student did wrong and what the misconception was, and that is where we will start class tomorrow. Have a wonderful evening. We look forward to